Alright guys, we're going to be doing something called graphing exponential functions. We've been dealing a lot with like exponents, exponential properties, so we're going to see what their graphs look like. So first topic is exponential growth, a function that increases. So the parent functions look like this. You will see y equals b to the x. So b is going to be some sort of number. 2 to the x, 3 to the x, and then x is the variable. With growth, the base specifically has to be bigger than 1. If it's less than 1, that'll be decay, and we'll get there in a little bit. What type of graph is it? It's continuous, it's one-to-one, it's increasing. And you will see all these things once I get the graph in front of us. So these are all just details that I'm writing down, and then you're going to see what the graph looks like. The domain is all reals. So that is important to note. Every exponential function, the domain will always be all reals. And the range for the parent function are just y values that are greater than 0. So just positive values. And again, you'll see it more clearly once I get the graph. We have an asymptote. Remember, an asymptote is a line that you will get very close to but never cross. And that is the x-axis. So it's horizontal. And then the intercepts that we always have is the point 0, 1. Okay, so again, these details aren't details that you should understand as of right now. I'm just writing all this stuff down. So our graph is going to look something like this. So exponential functions, if we take b and raise it to the x, I'm going to make up just a little table for you and just show you the 3 main points that we will always graph. We'll always plot -1, 0, and 1. We will have those 3 points on every single exponential graph. So if we do, let's start from the back. So b to the first. If we take whatever the base is and raise it to the first power, anything to the first power just gives you b. So we will always have the point 1b on our graph. Okay, so if we go over to 1, let's say, whatever that is, let's call that b. Okay, so we will always have a point right there. And then if we plug in 0, if we take b and raise it to the 0 power, remember from before, anything raised to the 0 power is just 1. So that's why we always have the point 0, 1. I wrote that down right there. So 0, 1 will be a point right there. And then if we plug in -1, b to the negative first, remember anything raised to the negative power flips like a fraction, so you'll have 1 over b. All right, so 1 over b will be some sort of fraction. So if we're over at -1, we'll have a fraction, maybe it's 1/2, 1/3, something like that. So through those 3 points, our graph will take on a shape something like this. It'll go up, and then it gets really large really quickly. All right, so some of the points here, all reals, you can plug in any x value. Y is greater than 0 because it starts at 0, you'll never see it below, it just goes up. The asymptote is the x-axis, meaning this line right here. My graph is just going to hug that line. And then I always have this intercept. So I'm going to write on the 3 points that I will always have on an exponential function. So this is the point 1 comma b. So no matter what the base is, I will have the point 1 comma b. So 1, 2, 1, 3, 1, 4, depending on what the base is. I will always have the point 0, 1. So this point right there will be on every parent function. And then this third point is the point -1, 1 over b. So the sooner you have those 3 points memorized, the easier it will be for you to graph. All right, so let's look at one example that we can see right here. So we are going to write, based on the points, our 3 points that we will have. So it's super important to have those points memorized. So remember, we've got the point -1, 1 over b. So we will have the point -1 and then 1 over 4. So I'm going to write these points right here. So these are the 3 points that you need to have memorized that you will always see on exponential functions. And as we graph, we're just going to sub in whatever our base is. So since our base is 4 here, we've got -1, 1/4. We will always have 0, 1. And then we will have 1, 4. So we're just replacing the b with our base right here. So we're going to plot those 3 points, graph it, and then state domain and range. So we've got 0, 1. We'll always have that point. And then 1, 1/4, so 2, 3, 4, will be right there. And then -1 and 1/4 is like here-ish. With the fractions, you just approximate. So we know the shape it's supposed to take on, so it'll just look something like that. Okay, so domain and range is nice and easy because this is just a parent function. Domain is all reals. Remember, we can do this weird double block R that represents all reals. And then the range is just positive values of y. Just y is greater than 0. Not greater than or equal to, just greater than. Okay, so now we're going to look at this transformed function where we can move left or right, up or down, stretch, flip, all the transformations that we've been doing with parabolas, square roots, all sorts of different functions. And we use the same letters. We still use H and K and A, so that hopefully that'll all kind of stick together. So horizontal translation is if you have H. Okay, so whatever value of H that you see, if you have X plus something or X minus something up in that exponent, that will be a shift either left or right. Okay, so remember, if you have X minus H, it's always kind of opposite. All right, so you're going to move X, it's going to be to the right, H units. Okay, and then if you have X plus H, remember counterintuitive again, that one would go to the left. So you're going to move X to the left, H units. Okay, vertical translations are the one on the end here, that's the K. So if you see a number like this -5, for instance, that's a vertical translation. So that's either going to be up or down. So if you see a plus K on the outside, you're going to move the Y value K units up. And if you see a minus K on the ends, then you're going to move the Y value down. So remember that K always does what it looks like it's going to do. So this would go down 5 units. So Y does what it looks like it's going to do, X does the opposite. And then orientation and shape, that will have to do with A. So A, remember, could either flip, compress, stretch, different things like that. So if you have a negative value, it's going to get reflected. So if A is less than 0, then it's going to be flipped over the x-axis. So it's going to be a vertical flip. It'll get flipped upside down. If A is greater than 1, then that will be a vertical stretch. And if A is somewhere between 0 and 1, like a fraction, that would be a vertical compression. Okay, so we're going to walk through exactly how we would apply these transformations. And the way we're going to do that is by starting with our original 3 points and then transforming them. Okay, so for this one right here, we've got y equals 2, we have an x plus 3, and then a minus 5 on the outside. So our parent graph, we call kind of the original, the parent graph. We would have just y equals 2 to the x. So what we want to do is first write down what the parent graph would have as its 3 original points, and then we're going to transform them. Okay, so our parent graph, remember we've got these 3 points, so -1 and then 1 over b. So we would have the point -1 and then 1 over 2, because 2 is our base. We always have the point 0, 1, and then that last one is 1 comma b. So because our base is 2, we would also have 1 comma 2. Okay, so that is the parent graph. That's before any transformations were made at all. But if you look on here, we've got an x plus 3. So what that means is that every single one of our x values is going to move to the left 3 units. Okay, so we're going to take these x values and we're going to move them to the left 3 units. So our new graph, all of the x values will move to the left 3 units. So I'm going to subtract 3 from -1. I'm going to subtract 3 from 0. And I'm going to subtract 3 from 1. So I took all my x values and I moved them left 3 units. Okay, so that's my starting. And then -5, I'm going to move the y values down 5 units. So from 1/2, if I go down 5, I'm going to be at -4.5. And then if I start at 1, if I subtract 5, I'll be at -4. And if I'm starting at 2 and go down 5, I'll be at -3. Okay, so once you take these little quantities here and make the transformations, you're going to plot this as a new graph. Okay, so I will have the point -4 and then -4.5. So that will be like right here. -3, -4, so I'll go down here and then down to -4, and -2, -3. Okay, so it will kind of stretch along like this and then just shoot up like the exponential curve. Okay, so it looks something like that. One thing to note as well is this, normally the x-axis is a vertical asymptote. When I moved down 5, I moved my vertical asymptote down 5. So you will have kind of this dotted line that your graph will never ever cross. So if we kept going to the left, it would just hug right along this line and wouldn't go below it. Okay, so that will help when we're doing the domain and range. So domain is all reals no matter what. It does not matter what graph you have. There's no transformation that you could make that would change that. The range, though, for us, it starts down here at -5 and then goes up. So it will be y is greater than -5. And it's this -5 right here that adjusted everything. Okay, let's look at another one. Another one, we're going to start with a parent graph. So our parent graph, before any changes were made, that was y equals 6 to the x. So doing these 3 original points, we would have -1, 1/6. They all have 0, 1, and then we would have 1 and 6. So those are my original 3, but I've got some transformations that are happening here. All right, so this x is just an x. There are no transformations being made on that x value. So all of these x values are just going to stay the same. Okay, so now the y value. 2 things are going to happen. First, I'm going to subtract 3, and then I'm going to multiply by 0.1. I'm sorry, actually, I'm going to multiply by 0.1 first and then subtract 3. So you kind of go from left to right. So I'm going to multiply this by 0.1. So let's do a little side work down here. So 1/6 times 0.1. That actually ends up being a nice 1/60th. And you could check that in your calculator. And then we're going to subtract 3. Okay, so if I start at 3 and I go down 1/60th, it's going to be a nice -2 and 59/60ths. So I'm just taking away one of those 60ths. Okay, so that's going to be obnoxious to plot. We're pretty much just going to plot it at -3. And then this one, so if I take 1, multiply it by 0.1, I get 0.1, and then I'm going to subtract 3. So that gives me a -2.9. And then this one, I start with 6. I'm going to multiply that by 0.1. That gives me 0.6, and then I will subtract 3. All right, so that gives me -2.4. And you could double check all those points in your calculator if you wanted to. All right, so we set this up. So we've got -1, and then most of our work is going to be down right in here. So -1, and we are pretty much at -3 there, whatever 59/60ths is. 0, and then we're at -2.9, so like right there. And then 1 is at -2.4, so right about there. Okay, so since we moved down 3, we do have that horizontal asymptote at 3. So it's going to hug the graph like this and then go up through these 3 points. So this one will have a much slower growth than this one did, and that's because it was multiplied by 0.1, so it got compressed compared to the other graph. So my domain is all reals, always, always all reals, no matter what exponential function you have. And then the range is going to move down 3 units, so it's going to be everything above that -3. Okay, so we're going to flip now and we're going to look at what the decay looks like. So I'm going to write down just some very quick info, and these points are all going to be the same. My parent function would be b to the x, but this time my base has to be somewhere between 1 and 0, so that I've got that fraction base. And same thing, it's going to be continuous, it's going to be 1 to 1, but this time it's going to be decreasing. My domain and range are still the same. My domain is all reals, no matter what. And my original range starts off as being greater than 0. And we know that could change if we do any sort of transformations. The asymptote is still going to be the x-axis, and the intercept is still going to be 0, 1. Okay, so these ones, when I plot this point, I'm going to show you what this little table would look like if I do -1, 0, and 1. If I take b, so b is going to be some sort of exponent. If I take b and raise it to the -1st power, I will have 1 over b, but b was already a fraction, so it actually gets flipped. So say, for instance, I flip 1/2, I get 2. So negative 1 over b will actually be somewhere up here, like that. And then 0, if I plug in 0, I'm still going to get 1, which is why I still have that same old y-intercept. And then if I plug in b to the first, I still get b. However, remember, b is now a fraction, so it's going to be somewhere down here. So it basically takes that graph that I had before and just flips it so that it's going the other way, so that it's decreasing instead of increasing. But I still have these exact same 3 points. I still have 1 over b, 0, 1, and I have negative 1, 1 over b. All right, so still keep those same 3 points memorized. We're going to do 2 quick graphs based on this. So this one is just a parent graph. So I can plot those 3 points, these 3 points right here that are super important. So negative 1, and then if I plot 1 over b means the reciprocal. So since right now b is 1/5, the reciprocal of 1/5 will be 5. So that's my starting point. And then I always have 0, 1. And then my third point is 1 comma b, so 1 comma 1/5. Okay, so let me plot those 3 points really quickly. So I have negative 1, 5. So that will be right there. 0, 1 as always. And then the point 1, 1/5 will be like right there. So this one has a pretty steep incline because the base is bigger than some of the other ones. So it just kind of drags along the x-axis, and this one's decreasing instead of increasing. All right, so this one wasn't moved up or down, so my domain and range are still all reals, and then the range is just the positive values of y. I didn't move it up or down, so it's still just greater than 0. Okay, let's tackle this one last exponential decay problem. I'm going to start with my original, so the parent graph is y equals just 1/2 to the x, whatever this base is. So my original 3 points, remember I have negative 1 and then the reciprocal of the base. So the reciprocal of 1/2 is 2. I always have the point 0, 1. And then I have the point 1 comma base. Okay, so those are my original. I'm going to make some transformations now. So my new points, I have an x minus 1. So x always does the opposite. So I'm actually going to add 1 to all of my x values. So I'm going to add 1 here, I'll get 0. Add 1 here, I'll get 1. Add 1 here, I'll get 2. Okay, so now for my y values. I am going to multiply by negative 4 and then add 2. Okay, so if I multiply this by negative 4, I get negative 8. And then if I add 2, I get negative 6. Okay, this one. If I multiply 1 by negative 4, I get negative 4. And then if I add 2, I get negative 2. And this, if I multiply 1/2 by negative 4, I get negative 2. And then if I add 2, I get 0. So these are my 3 new points that I'm going to plot. Let's take a look at what that looks like. So 0, negative 6. Be right there. I have the point 1, negative 2. And then I have the point 2, 0. So right there. All right, so this plus 2, remember that means that my asymptote has jumped up 2 units. So it'll be right here. So my graph will look something like this. It got flipped upside down, and it's got all sorts of other transformations happening here. Okay, so let's be careful with this domain and range. So our domain, always all reals, that will never ever change with exponentials. Our range, our highest value is 2, and then the graph goes down from there. So this will actually be y is less than 2. This is our first less than, and that's because we have a negative out front, which means our graph flipped as well as stretched. All right, so we are all set with this section.